Hey, hello and welcome to the show. It's me, John Park, and it's time for John Park's Workshop. Thank you for the people in the comments section there over on our Discord who noticed new theme music. I got bored of my previous theme music, which was a song I wrote years ago, so I picked this one, which I wrote just like a year ago, so I'm modernizing. So let's see, what's happening here? My glasses are clean. Dave Odessa over in the YouTube chat asks, am I on the right channel? I know, it's shocking when things change. That is a new song. Andy Calloway over in our Discord says, it's the voice of Lars. I'm not going to admit to that for sure. That's creepy. What else is happening here? I noticed something disturbing. Actually, there's two disturbing things here. One I knew already, but you may not have, which is for all of my interest in mechanical keyboards, the one I use for this show is just this membrane, this dirty membrane Apple one. All of my keyboards are really clicky, really loud, so I have not been using a mechanical keyboard here to drive this show. But that may have to change because here's disturbing fact number 2. I think I have battery swelling. Can you see it? It is here. Right there, look at that. You see that right there? This is a wireless keyboard. I think the battery is swelling, which is disturbing to say the least. So, if I burst into flames, that's why. That's probably why. Yeah, that's probably it. So I got to do something about that. I'm going to have to build a keyboard. I'm going to have to build a keyboard with some silent switches, a nice mechanical one with silent switches. That's my goal. That's what I should do. Maybe a small one, maybe like a 60% or something like that. We'll see. All right, what else is new? Hey, we've got this. We've got this help wanted sign up right here, and that's because there's a jobs board over on Adafruit at jobs.adafruit.com. And look, if you head over there right now, here's what you're going to see in the for hire section, the available for hire section. You got to be logged in. You have to be logged in with your Adafruit login to get here, as well as to post your resume and what kind of stuff you're looking for. But there's always interesting things here. So if you're looking for maybe someone local, you can search by location. You can cruise on through and just browse here. I noticed we've got an engineer here who's doing R&D work somewhere and also looking for work. I saw down at the bottom here, art and design, factotum ad nauseum. Go check that out if you're looking for an artist slash designer slash photographer to help you out with the project. So that's jobs.adafruit.com. Head over there to check it out. I'm laughing because, I shouldn't laugh, but hey, we got keyboard suggestions. And I saw that CryptNip just picked up a Newfie Air 75. I have to look that up. I don't know that one. Newfie Air 75, 75% keyboard. I like those. But the one I'm laughing about is Blitz City DIY said, Gherkin! I built a Gherkin. There's no way I'm using that thing. Actually, that's my Wordle entry thing because it's just letters. It's pretty much all it is. Those are good suggestions, though. I'll check out the one you got there, CryptNip. Thank you. What else? Oh, thank you. Cryptnip said sounded awesome. That song, I put that together on my 1010 black box. And black box, oh, I just got a call from a telemarketer in Orlando. I don't want that. Go away. Yeah, that was some sample drum packs and such. I can't remember what the audio, the vocal audio was originally. It might have been something I sampled myself, but fun sample workstation, the 1010 Black Box. What else? Hey, I've got this show that I do on Tuesdays. It's called JP's Product Pick of the Week. That's what it looks like right there. And even more so, that's what it looks like this week. So this week I had this one. 2 different products that were on a deep 50% off discount during the show. Usually I'll do software, hardware demos. Not a lot to demo on this one, I will be honest. It's hookup wire, but it's a good set and it was at a great price. But I'll give you a little recap just the same. So take it away, me. The 10 and the 6 solid core hookup wire spool sets. These are 22 AWG, and they are perfect for breadboarding and prototyping. We get white, black, gray, brown, dark purple, blue, green, yellow, orange, and red. Look at the set of 6. You get the blue, white, green, yellow, red, and black. Here's how you use them. So I will just take a little bit off of the ends of my wire and end up running them like that. The solid core, this gauge works great. 22 AWG works great for pressing them in and getting a solid connection. This isn't falling out easily. I first built this on a breadboard, then I just moved it over to the PermaProto and was able to make sense of my wiring and match my fritzing diagram. That's my product pick of the week. This week it is the 10 and 6 spool hookup wire set, solid core. Yes, indeed it is. So next up, what am I? Ooh, I'm getting messages. What's that? Oh, I'm gonna take a look. I just got a DM. Ooh. All right. Get back to JP is wired, says Andy Calloway. All right. Next up, let's do a CircuitPython parsec. All right, sorry if that was echoey, that might have been echoey. For the CircuitPython parsec today, what I wanted to do was extend the lesson we did last time. What I want to do is show how you can use the color of a coordinate in a bitmap like a pixel in order to make your own DIY, roll your own line drawing routines. So if you take a look at the screen here, I have a little feather with the TFT feather wing. And in my Atom session, I just have it doing nothing at the moment, just so I can get a blank screen. What I'm going to do is, let's just uncomment this one line of code and save it. So this is a little procedure I made called draw horizontal line. And you can see there I'm feeding it an X position and a Y position to start, a length, 100 in this case, a color for my color palette, and you can see I also have it sort of draw on dramatically by putting a little pause there. And I'll just add one more to that. So let's also draw in a vertical line. So these are the 2 procedures that I built, draw H line and draw V line. And you can see them right here. Here's how they work. So first of all, I'm using display IO and I'm using a bitmap that I have put inside of the display group. And I have a little palette of colors here. When I call one of these 2 functions, we feed it X position, Y position, length, color, and the pause, which will default to 0. And then we loop through the range of the length. So in this case, I was going 100 times, looping through this next section, which says, hey, bitmap, set this position on X and this position on Y to whatever color from our palette we have selected, and then pause if there's a pause called for there. And all this does is change the palette value at that pixel, which has the effect of drawing. Now you can see if we want to do some extra fancy stuff here, we can make little line drawing procedures. Here you can see I've got sort of my own version of a very old school looking video game level drawing on. So we got a little ladder, we got some ledges here drawing on. We don't need to have the pause in there, we can pull those out. And in fact, what I'll do is actually delete this right here. So these will no longer pause. They'll just use the default, which is 0. So we don't even have to type that in. That's a default for the function. And now I'm going to change the color of the palette once I've drawn it on. So we've set down pixels, and then you can see it blink white there on that one palette color, and that's because that position doesn't really know what the color is. We can swap it out. That position really just knows what its palette index is. And so that is how you can roll your own horizontal and vertical line drawing using bitmap inside of display.io in CircuitPython. And that is your CircuitPython parsec. And yes, thank you. Todd pointed this out. I realized as I was saying, give it an X position and a Y position. It does seem like I'm either talking a lot to it or we've set up a county fair or something. X position, kind of a confusing word in English. All right. So let's move on from there. What else have we got going on? Let's talk about the coupon code of the week. So I'm not in the habit of this. I got out of the habit, but it's back. Here comes coupon codes, hot and heavy. Sliders. That is your coupon code this week or for today. If you are placing an order, just head on over to Adafruit, and during checkout, you'll see a little coupon section or a coupon code section. Type in sliders with a Z. I don't know why, it just looked fancy. Type that in and you will get 10% off your entire order. This excludes software gift certificates. My gosh, that's a hard one to say. This excludes software gift certificates and subscriptions. And so you can get products, stuff, any of the stuff pretty much in the store. I don't think there's any exclusions there. If it's a physical good that you can have sent to your home, do it and get 10% off. So head on over. That will be good until midnight East Coast time tonight. So that's good all day long. I'm tripping on my mic cord here. Sliders is your coupon code. That'll get you 10% off. So head on over to the store. Pick some cool stuff. Speaking of the store and cool stuff, here's my store. I can move this out of the way. Hold on. Whoop. Let me just drive that there and just, hey. So what's new in the store? If you're wondering, you can head over to products, and this new products section pops up here. View all on that, and that'll give you the latest things in the store. So you can see we've been building out our pre-assembled backpacks, both for the 7-digit and the 14-segment displays. So really cool, especially because these now have the Stemma QT port on them. You don't really need header pins on them. You don't really need to do any soldering to use them. So if you have something like a QT Py or one of the more modern Feathers, KB2040, and you want to plug stuff into it, just go over Stemma QT. And with these pre-assembled ones, you don't need to worry about any soldering at all. Here's an upcoming product that I'm excited about, actually. It's this quick Stemma QT 5-port hub. So it's a passive hub. It just connects up wires on that I2C bus, but it allows you to do a sort of hub and spoke arrangement instead of a chain where one Stemma QT enabled thing to the next, to the next, to the next. So depending on the topology of how you're setting up a project, this can be really useful. Also, there are some items that don't have a pass-through just because of board space. I think there's some of the displays you'll find. I don't know, is this one of them? No, this one's not one of them. But some of your displays, I noticed, just have a single Stemma QT. So this helps with situations like that. Some new sensors coming out. Again, I'm very excited about this stuff here, these iSpy breakouts, which will be a little ribbon cable that allows you to connect up to SPI displays without doing all that soldering, which will be fantastic. So those will be on microcontroller boards, dev boards soon, but right now you can use this little breakout board to at least get there. Also, a bunch of these inductive wireless LEDs have been coming out in 10 packs of the different colors, of the large-sized ones. So just some stuff that you might want to check out in the store and use that coupon code right there to get a nice, juicy discount on it, 10% off. Questions from the chat. Let me bring up my Discord view here. DJ Devon3 says, what are some use cases for spoke versus daisy chain? Does it make a difference in how some things might work? It should not. It's a passive connection, so it is just presuming one I2C bus. Things need unique addresses. It is just a physical arrangement. And so I don't have any good examples right here, but as you plug things together, if all of your physical objects are in one space, like the Walkman project, for example. If you have a lot of stemma QT things plugged in, running those cables from thing to thing to thing means you're using longer cables probably just to accommodate the space. So that's what this sort of hub and spoke arrangement gives you, is you'd go from your controller board to this and then out, and so everything can have nice little short hub and spoke runs. What else? DJ Devon asks, can you combine a JP coupon with an Ask an Engineer coupon? I have no idea. That's a great question. Try it. We won't throw you in jail for trying. Probably not. I think they're exclusive. There may be some language in the coupon code page. I think we have a page about coupons. Probably not. Also, I think they tend to expire before the next one. So I think the Ask an Engineer one should have expired last night, but I think sometimes PT keeps that one on. So. Follow-up supposition from DJ Devon 3 is maybe the power draw farther away on a long chain of daisy devices. Yes, I2C doesn't really want to be on long runs, so if you can keep the runs shorter of cabling, that's better, and that's a case where hub and spoke may also help you. All right, let's see what else is happening. So why don't we jump into project stuff? So you can see here I very suggestively called today's episode Darth Faders, and credit to Janiscu7, who I think posted a Darth Fader meme GIF on our chat last week when I was looking at faders. So these are the faders we're talking about. I did a project a few weeks ago of just showing how to use that as a motorized fader that can go to a pre-saved position. It has servo control because of the analog, and allow you to still control things. In my case, I was using it for some MIDI control. Last week, I went into some of the details of controlling that brushless DC motor using more advanced techniques. And this was based on C. Grover's excellent guide. And so I showed how you can adjust the PWM frequency and the throttle to get the kind of speeds you want and still have enough oomph without too much stepping. So that's that fine tuning you can do. Reason I was really interested in getting slower motion on this instead of using PID to whip places as quick as I can without overshoot is that I wanted to build a sculpture. So you may have seen, I showed this off last night on Show and Tell, but we're going to get a little deeper into it today. So I've built a sculpture using 3 of these and a motor feather wing. Why don't we head over here to the bench and we'll take a look at what I've built and where I'm going with it. Actually, I'm going to probably pull this apart so that we can swap out the bottom, and you'll see why in a second here. So let me head on over here and grab my iced tea on the way. And yeah, that's good right there. I'll have to remember to turn that back on. So here you can see is my 3D printed case for 3 of these faders. Now, right now you could just plug this in over USB. There's a feather in there, and we could use these faders as just a kind of fun, oddly shaped control box. This will sit vertically or on its back here. It's pretty flat. Or you can also set it up on some of its sides there, depending on the cabling you have coming out of it. And so these are controllable when the motors aren't moving them. When I go ahead and give this power over USB to the feather, you can see this is my latest edition. I didn't have this hooked up last night, but this morning I hooked up a rotary encoder using one of our little Seesaw rotary encoder stemma QT breakouts. And this is a rotary encoder with a push encoder. So you can see here I can click, click. So that's a push button. So I have that doing something right now. I'll show you. This also has a little NeoPixel for feedback on it and power and so on. And I put one of our really nice new anodized aluminum knobs on there in keeping with the sort of Darth Vader theme. By the way, the purple's going away. That was a sort of throwaway filament that you can see isn't in such good shape. This black filament I've got right now is working a lot better. So we're going to replace that in a second. And oh, here's a nice suggestion from the chat. Todd says, can you make the faders move in a Darth Vader breathing way? That's a nice idea. So now what I'll do is plug in DC power to the motor feather wing driver. So that's what's driving these. And you can see it doesn't do anything. It's still just free running, free floating here. But what I'll do is click the click encoder to enable movement. So I have this functioning right now as essentially an on-off button. And so that starts a little cycle of animations running and then runs forever. So this will run a little pattern I have. It's, I think, 6 steps. Oh, I noticed it's doing a little, I wonder if it's a little different when it's vertical. We'll tune the values. Yeah, I think in vertical it's not doing that overshoot, but in horizontal it is. So the tuning of the throttle and the PWM, the orientation of it actually matters. So I can press the push encoder button and that stops the animation right where it is. Also gives me free running. So I'm not using the capacitive touch right now, and I might not on this project because we don't have any of these for sale yet. Lady 8 has been trying to source these capacitive touch fader caps. They're actually kind of hard to find. So I don't think I'm going to use that. In my previous project, I did show how you can essentially disable the motor when you're touching it and enable it when you release. So on this one instead, I'm just hitting my little push encoder button, and that resumes the animation from where it was. So you can see right now we're stopped at the middle. We're going to be heading up. If I pause it and continue, we're still going through the cycle of animations that we have. So that pauses it. Rotary encoder right now isn't doing anything other than as a print statement. We'll take a look at that over on the workstation in a minute. But I have a couple ideas for things to do. I'm interested in people's feedback of what does this sculpture need from a rotary encoder. One idea is to have some different pre-saved animation patterns that you go to. Another is to just step through each individual little step of the animation for fun. This could also be used as automation for, let's say, a stereo mixing board, or for values for MIDI sliders or CC going through a converter for synth stuff, video mixing, all those good things. So maybe having granular control of heading to a preset instead of just going there would be nice. One thing I'll show you that I've tested using it for, which is kind of fun, is adjusting the speed or the PWM frequency, which allows you maybe to use a calibration mode to just tune it until you like it, write down the number and save it, or get even fancier and have something like a double click put you into that mode and then store that value. So let's look at code stuff, then we'll come back and pull it apart and put on the new version of the bottom here that I built with just a couple of refinements. So I'm gonna take I'll leave the DC power here. By the way, one thing I'm going to do right now, because I keep saying I'm going to do it, and it's a little tip. This is 9 volt. This is wanting 9 volt. There's a lot of these barrel connectors around that I'm really liable to plug something into and possibly damage things. So I'm going to wrap a little bit of either heat shrink or electrician's tape around that. I don't think this is big enough, so that I remember that that is 9. Oh, here's some heat shrink that might work. Oh, actually, this is from this nice pre-cut little shrink kit from Adafruit. And there is a pretty wide gauge red, maybe wide enough. Let's see. Almost wide enough. Here's another life hack. I'm going to cut this and then I'm going to stretch it with some pliers. So it's probably not how this is meant to work, but it works usually. So let's get a little piece there. Let me zoom in for for a second while we're doing this. So you can actually use your scissors for this too. All you want to do is, yeah, that's a little big. I'm going to grab some needle nose pliers. Longer handle is better. And set about stretching that just a little beyond what it wants to. There we go. Now we have a diameter of heat shrink that we did not have before. And I'll just give this a little quick hit with the shrink ray gun here, just to tighten that up again. I'm sure there's reasons not to do that, but it seems to work pretty well. And actually, if I'd use this heat shrink on this guy here too, let's see, will that fit? I can probably write with a Sharpie on this, which is easier than this piece of electrical tape. But you know what? I'll do it anyway. So let's do 9 volt, 9 volt. You could write DC on that too. I won't for expediency, but at least that lessens the chance of me really ruining something with the wrong voltage. Okay, so let's take this over here. And I'll rearrange some stuff here so we can all see. Let's do this out of the way. You know, I'll try to keep this in camera view vertical like I did on the show last night. Let's see. Put a little beautifying junk blocker behind it. And I won't subject you to this camera movement until I have it sort of dialed in. There is going to be a, let's see. Yeah, that'll work. I need to block a light from pointing in it. All right, so let's go to that view there. And so here's my little rotary encoder knob. Let's plug this into USB. Shing. And I will grab my DC power source. And look, I don't have any question if it's the right one because this is the red band that says 9 volts. So that's good. So we'll plug that guy there. Da-da-da. Okay, so that's working again. And yeah, Todd over in our chat said the worst thing is all these guitar pedal people who use the 9 volt DC barrel connector, but the reverse polarity center negative. Yeah, that's a shocker when that happens. Keep the guitar stuff separate from the everything else stuff. Okay, so excuse me, I'm going to go ahead and open up the code that's on this. And okay, so here's the additions to this code that are related to this encoder. So I have my little stemma QT set up here with the seesaw for the rotary encoder, and for the button I'm using that with the debouncer library, and it just changes this last encoder position as I move it, and it switches the button state, where is it, move state, from false to true. My main code is this right here, and now I've wrapped it inside of if move state. So that means that when I click the encoder button, the debouncer notices it and then just changes the state back and forth, and it flips that variable. So if the move state is false, then none of this happens. If it's true, then all this happens, which is my little function that goes from position to position. In the case of the rotary encoder, so let's see, I'm going to reconnect the REPL here. So you can see when I press the button, I'm printing out move state is true, move state is false. And when I rotate it right now, I'm just printing out the position. So this is kind of the absolute position. But what I kind of care about more is the delta. So if you look at this encoder position code, encoder position, I've reversed its direction just because clockwise and counterclockwise were kind of backwards from what I wanted using this. And then if my encoder position isn't the same as my last encoder position, which means I've touched it, moved it, then we do the following. I have a variable called encoder delta, which is the encoder position minus whatever the last encoder position was, which is the state variable. Let me print that out. The encoder delta should just be a 1 or a negative 1. So if I'm moving to the right, this is kind of like how a mouse works. A mouse just sends a little relative -1 or +1 on each axis. So this means I can now add onto something or subtract from something. So to do something like change the speed, what I'll do is let's look at how the speed works. Right now, top of the code, this is all based on the stuff that we did last week. So setting this motor frequency, that's the pulse width. So as this goes lower, it gets steppier, but we get more oomph. And then my max throttle value right now, that's essentially what the speed kind of boils down to. That's the easiest way to say that's how fast it's going. So that's 0.2 of the voltage that the motor feather wing sends to that motor. Excuse me, so max throttle, I can reuse that variable over here in my update position. This is what moves the motor. It's what moves a fader or all the faders. So it gets sent these arguments of which fader, so we usually cycle through all 3 of them, and the new position where it's headed. So now let's add one more thing to this, which is going to be max throttle. And if we feed it that variable, when it goes to actually turn on the motor, because it's set to none when it's not moving, it's going to grab max throttle that I can now change, and it's going to get the new value of that. So when I want to ask for this update fader position, I now have to feed it a 3rd argument. So let's go down here, update position. It's saying which fader, which pre-saved position from the pre-saved position list, and the throttle value. This doesn't have to be named max throttle, or does it? No, it doesn't necessarily, but I will. How about? So I don't get super confused. I know I'm doing bad things as far as global variable names, sorry. And this should work the same. Nothing should change here. Let's just test this. All right, so it's still moving, and this is the throttle value of 0.2 that it has been in the past. So now what I want to do is be able to increase or decrease that throttle value as I rotate my encoder. So if we look at this encoder, if the position has changed, I have these encoder delta of 1 or -1. Right now I'm just printing that, but how about we say max throttle equals max throttle plus 0.01 times encoder delta. So since my values are pretty minimal, I'm going 0.2. This means if I rotate 10 clicks on the encoder, we'll have gone up to 0.3, and that's actually quite fast. So this will be a pretty rapid change. Let's see how it looks though. Let me add a little space there. So again, starts out, just uses the starting value of 0.2. So let's slow it down. It probably won't go much slower without starting to stall. So you can see they're really kind of creeping along there. My code doesn't actually wait for them to arrive at a position before moving on. It just is a time-based, there's a period right now, which is kind of nice, so we're not sitting forever, but you could change that. So let's get even a notch slower. Okay, so let's pause right there. So why is this useful? Well, it could be part of how the sculpture works, how Darth Vader works. And by the way, the reason I started calling it Darth Vader, besides Yanisku's excellent Darth Vader memes in the chat, is that it's so ominous looking. This design that I built here just has this kind of ominous look, like the soap dispenser in Darth Vader's bathroom or something like that. So what I'll do is I'll start printing the max throttle. So let's get rid of that. And this means I can interactively pick a number that I really like the best. So let's do print max throttle. Save it, hit play. Okay, so let's tune that up. So here's 2.1. Let's see what's the smallest. Where does it really stall out? That looks like it's too small, so 0.16, no good. I arrived at these before just interactively, right? So save, change, save, change, save. This is much nicer. It's also interactive, but it's a lot faster interactive. What about top speeds at this particular PWM frequency? How fast can we get going before it's... Okay, you can see already at 2.23, we're starting to hit a little oscillation, a little judder, and that's because I don't have my PID code in here anymore. Maybe I'll add that back in so I can get super fast, right? Because you can really whip this thing around so long as you can avoid backlash or overshoot. So let's just go crazy fast. It won't hurt it. So you can see they get there, and for the most part, they flip out. Some of them are behaving better than others. Let's go real fast. So top speed will be 0.1. I'll leave it at that. So that's all overshoot. They're just never getting, you can see they're kind of changing, favoring the bottom and the top. Pause that, right? That's nice. Maybe I'll just put a microphone on this thing and this is the instrument. So what we can do just for fun right now is change what the high, medium, and low values are. Just keep it in a little narrower range. So let's say high is 160, medium is 120, and low is, how about 80. Now this overshoot may just still be tremendous, but here I'll run it first at sort of a moderate speed. So you can see they just don't go very far. And this will just prevent it from clacking around at the extents. Probably. Drop this back down. So you could really, for dialing this stuff in, what you could do is find out a relationship, sort of a proportional relationship between the PWM frequency and the throttle. And again, you may have to have two knobs for that so that you can dial them in, or maybe click the knob to change it. But this could be really a nice way to do calibration before you stick to some numbers. And this would all change if we put different weights on this, right? So I've got these little fader caps, they're pretty light. If you put a Lego piece or a piece of rubber band or a balloon or who knows what, you're going to vary what you want your speed and your PWM frequency to be. So having a couple of knobs for that could be cool. And it could be, like I said, a calibration procedure. So maybe if you're holding that button during startup, it would allow you to get to something you like and then lock it in and store that value. Oh, Starman in the chat just said, if you had some nudes hooked up, which is our little rubbery LED filaments between the sliders, it would make the nudes go like a wave motion. I was, we're thinking alike. I was trying that. I didn't light one up, but I just kind of affixed it to them to see it moving around to see if it made good wave patterns. But I was going slow with it, and I think you're right. I think if we're going real fast, that could be cool. We could get, maybe if they're fixed at one end, this could be kind of like jump rope or something like that, making them move. Who knows? It's more of an experiment and a piece of sculpture. So, all right, so that's what I've got. Let me put my default values back into here and just see that it's kind of working. Looks good. So now what it will do is take a look at how it's put together, and I'll swap in the new base. Before I do that, let me know if you got any other questions over in the chat. Over in Discord, I see, here, I'll pop up the Discord right now. Mouse said, question for John and Liz, how the heck do I plug in the last Eurorack module? There's not enough room to reach in to plug in the power cable. You're putting together a rack and you can't get that last power cable plugged in. I start with all the power coming off of the bus board and dangling out of the case. So the last thing you should be doing is plugging it into the module. Let's see. Other questions? Yeah, Starman, that would be cool. With the fast move, we might get like sine waves and stuff like that, which would be really cool. And actually, PT said he wanted to see some, if we could get LEDs involved with this, it would be cool for doing maybe some long exposure photography, which could be pretty fun too. All right, so let's jump back to the workbench, and I'll pull this little Darth fader apart and put it back together with the new base. So I've been designing the case for this using Rhino, and most of it is based on some curves that I drew, and then I derive everything off of these sort of base curves. And I forgot in one case to add an offset to allow for the expansion of the 3D print, because it's not perfect, and I'm thinking more of a laser cutter world where the cuts are basically perfect. So when I did the first base and the first walls, which is what I'm calling the main part of the case, you can see here I cracked this because this was just too small. You can see it's a little bit bent here. Let's see here, get some focus. So you can see this is a little bit bent because these two thought they were occupying essentially the same exact spot in space, but 3D prints are a little fatter than a perfection, an ideal. So that one snapped on me. So I haven't reprinted this one yet, but I will put in the new case. Maybe I'll glue that later. So I'll show you how this is assembled. First of all, I can pull off the rotary encoder. I don't have a spot for that yet. I'm thinking of just putting it on the side. Either just drill out a hole on this case and glue that and be lazy, or put a real hole in it in the 3D model, which is probably what I'll do. So I can upload that for the guide and have a nice spot for that to hook to the case. So let's, might as well take it all apart. So I've got this cap. The only thing holding this together are the 3 M3 screws at the top and the 3 M3 screws at the bottom that go into the faders. So the faders actually are kind of part of the structure, just because they're metal and they have threaded holes. And actually that's another case where I made my holes basically 3 millimeter, and you've always got to accommodate for 3D prints being a little wide, and I forgot, so I had to kind of gouge those out a little bit with a hole reamer. Where is that hole reamer? This kind of thing here is the best to make your mistakes go away if you're forgetting to add to the hole size. You can also see I got a little impatient, or I didn't put enough of my sort of glue stick Magigoo down on my glass bed that I print on, and this part here stuck and warped a little as I was trying to peel this off. So that's the lid. It just kind of sits on top and has these 3 holes that screw into the faders. Faders, you can see, they're locked in down at the bottom, and there's some little walls and the screws, but they do wobble a little until we put that collar on top. So now I'll unscrew the base here. Actually, don't have to do that. This just pulls out. So right now, this is just sandwiched between the layers. So that pulls off like that there. Very Darth Vader-y. And this is where you can see I probably should put some support in the model so that these are a little stronger. So just essentially run a kind of a fillet or a chamfer down that to make all these a little stronger. So that's the walls of the thing, and you can see it actually stands alone, much like poor old Darth Vader with his mask off. You get this gross innards wiry thing. So this can be freestanding as is. It wobbles a little, but these aren't really going anywhere. In fact, let's plug it in just for the fun of seeing it running exposed. So let's plug that there. I'm just going to bring up my Discord to make sure you're not warning me about my sound going away or anything like that. So let's get cabling. Okay, so you'll see when I plug in the 9-volt power, you'll see the little light goes on right there, the little green light on the motor driver. So that just means that the external power that's being regulated by the motor driver is there, but I'm not powering the logic. And this is a good idea with anything that's driving stuff with a decent load. Motors usually have a separate power supply from your logic so you don't get little brownouts and confuse things. So now I've got my USB plugs into the feather right there. Just got a little USB hub there. So now this is how I can tell the lights are on. The feather's got power because it's powering on the stemma. And yeah, you can see it maybe from the main cam if I turn it like that in front of me there. Or from the top-down cam. All right, so this is an alternate. You could also do a clear or a diffuse translucent body for it and put some lights in there. You can do all kinds of cool stuff. I'm trying to keep it somewhat reasonable. And go ahead and turn that off. Now let's pull it apart. So easiest way to do this, I've got a set of pegs that the terminal block feather wing are just resting on. And I actually lengthened those on my revised one. They were a little short due to the length of all this stuff soldered in, all of those terminal blocks. And now unscrew these 3 faders from there. I don't have them numbered, so you do kind of have to pay attention to which one's which. I could probably put a little piece of tape or something like that. You could always change that in code, but you don't want to, I say. Okay, so that's the base there. You can see I've made my wiring fairly short so that it just works in place. You don't have a lot of leeway with these based on how I wired it. And so the real changes to this, there's 3 of them. 4 of them actually. So I've made this lip a little deeper in the back. I've made the little pegs a little taller. And those could be like heat set inserts and screws for the terminal block feather wing if you wanted. I decided to go the easy route. And then I've made it just a little bigger, so it'll accommodate, hopefully, the size of this without bending. And then I also removed a little chamfer that I didn't like. I have this little corner here, which I don't like. And it was made with this terrible lavender delaminating, not working on my printer very well anymore. Must have gotten moisture or something like that. This stuff, however, is printing pretty well, so ignore that broken bit there, but this should now fit into here much nicer without all that bending in the back. Yeah, so much better. That's really not bent to live in there. This one is a lost cause at this point. So that should be a better fit. And then put it back together. We'll just kind of plop everyone in place all at the same time. So this will drop onto those little pegs. This will go here. Oh, forgot. Should do this first. I need to remount those holes a little. I didn't. That's one thing I did not revise when I should have. It's the size of those holes. So these don't have to go in easy, or you can make it hard and they'll thread in there, which is nice, but they won't even get started right now with the size I have. So I'll just come in here. If this reamer has even got a small enough, maybe. I was using the tip of a X-Acto before. Even a little bit of a chamfer there will give it, the screw, a little bit of a prayer of starting. There's one nice thing about 3D print, is it is pretty forgiving to you going in and modifying it later, within reason. Will it start? No, I'll make that a little. This will work better. Remove a bit of. Yanisku says Darth Lars knobs for faders could be legendary. Darth Lars. That is a Sith I do not wish to encounter. Right, Lars? You know what I wish I had is a little tapping bit for this screwdriver, this type of removable. That would be nice, rather than getting the real tapping stuff out, just one that would fit that profile. Oh, if you're not checking out the chat, you should, because there's a cool project that C. Grover has been working on using palette color swapping. He's got a Larsy example up of knocking out a green screen. So go check that out. By the way, the decision to go with 3 instead of 4 faders was all about the physical design, but then as it turns out, that's a really convenient number to do using the terminal screw shield, because you have 3 different ground and 3 different 3.3 volt blocks on it, which is what you need for reading the slide potentiometers. So it worked out really well. There's 4 motor driver outputs on the feather wing, so you could drive them, but without having to do any extra work. I could just screw into stuff that's existing, which is nice. Happy accident. Okay, so those are pretty good. Looks like, drop this on. And the only fiddly bit here is just feeding some of this wiring up. Just to get it out of the way. I could probably dress that better with a cable tie or a zip tie or something. Oh, I got one of these on the outside here. These flex a lot because of the construction. There we go. That is a much nicer fit, though. And lastly, I put the hat back on. And I won't screw that in now just because you don't want to watch that. I'll just rest that on there. But here we go. We are back in business, and now with a nicer fit. I can plug in my rotary encoder again. Feather. Power. Start it up. You see this is a little sloppy up here because I didn't put those screws in yet, so this will sit at wonky angles. Let's get it going crazy. Woo! Calm down. Yeah, much better. Yeah, that's what this is. This is going to be Darth's breathing apparatus when he goes to bed at night. It's a sleep apnea mask, basically. That's what it'll be. All right, that's enough of that. Let's jump back over here and finish this thing off. So thanks, everyone, for stopping by. The stuff I was mentioning in the Discord, there's a nice example of Seagrover's green screen work. He took a photo, I gave him a photo I had of Lars on a green screen from one of the AdaBox videos, and he's using that for his test case, which I love. Kind of like the Kodak model woman from the 70s, I forget her name, who got used in all graphics research. Lars is the new that. Oh yeah, there's lots of good lots of good Anakin, Darth Vader stuff there. Any other questions? Looks like Mouse got the new module plugged in and you think it's working. That's excellent. Darth plays harmonica and good, we're all caught up. DJ Devon, love stemma, makes everything so much easier. I agree. Boy, that's so much less wiring. Maybe we'll put the motorized faders on a stemma board. That would be nice. Okay, that is going to do it. So did I miss anything? I think not. Last thing I'll mention again is we've got this coupon code right here. Let me try to move it. That didn't work. Sliders, that's going to get you 10% off in the store. So head on over at Adafruit.com, go to the store, look at new products, look at old products, pick some stuff you want, and get yourself 10% off on the way out. Just type in that coupon code. It'll take care of it all for you. That code is good until the end of today. East Coast midnight is when it turns into a pumpkin again. So go use that sliders code and get yourself some Adafruit stuff. Build some cool things. These faders are out of stock right now. So if you want, you can sign up to be notified when they come back in. If you want to build a project with these, they're super snazzy. All right. Well, hey, thanks again, everyone, for stopping by. That's going to do it for this week. For Adafruit Industries, I'm John Park, and this has been John Park's Workshop. I will see you next week. Bye-bye. New song time.